This is OpenNMS 101 again, Module 11, Part C, Graphing SNMP Data. Create a graph of the Tutorial 1 metric created in Module B. Graph definitions are kept in the OpenNMS home/etc/snmp-graph.properties.d directory. Use the graph current TCP connections as the template. This is largely a copy-paste, search and replace operation. Begin on the localhost front page and click on Resource Graphs. Select the Node Level Performance Data checkbox and click on Graph Selection. Scroll down a bit to the Current TCP Connections graph. Click on the binoculars to isolate the graph. Switch to the console and display directory OpenNMS/etc/snmp-graph.properties.d. Search for the graph name Current TCP Connections in the Properties file. The graph is defined in the mib2-graph.properties file. Edit mib-2 graph.properties and search for current TCP connections. In another console in the same directory, touch tutorial.properties. This creates the file tutorial.properties. Change the ownership of tutorial.properties to OpenNMS. Change the mode of tutorial.properties to 664. Edit tutorial.properties. Return to mib2-graph.properties and copy the definition of current TCP connections. Return to tutorial.properties and paste the definition. There is an element mib2.tcpcurrent. Search for it in mib2-graph.properties. It turns out that this is a report name. Just copy the reports line into tutorial.properties at the top of the file. In tutorial.properties, change the name of the report to mib2.tcpcurrent to ease the search and replace operations that follow. Search for mib2.tcpcurrent and replace with tutorial.demo. Search for current TCP connections and replace with tutorial random numbers. Search for TCP cur estab and replace with tutorial 1. This is the metric alias. Search for cur estab and replace it with tut1. Save tutorial.properties. Return to the localhost front page and click on Resource Graphs. Select the Node Level Performance Data checkbox and click on Graph Selection. Scroll down the resulting page. It seems that the tutorial graph is not present. Refresh the page. Scroll back down to the bottom and the tutorial random numbers graph shows up. Click on the binoculars to isolate the graph. Using copy-paste, search and replace, a new graph has been added to OpenNMS. Besides cutting and pasting, searching and replacing, it might be helpful to understand how graphs are defined in OpenNMS. OpenNMS covers graph definitions in the Horizon Operations Documentation, Deep Dive, Performance Management, Graphing Metrics. Full coverage is beyond the scope of this tutorial. The RRD tool command syntax is explained on the RRD graph webpage and the RRD graph_graph webpage. Links are provided at the bottom of each of the preceding RRD tool web pages, cross-referencing more detailed information. Within a properties file, each graph is referred to as a report. This report is tutorial.demo. Multiple reports, and therefore graphs, are listed as a comma-separated list of report names that are defined later in the file. The insert is from Zeus-graphs.properties. Note how multiple reports are listed. Note that there is a new line between the last report name and the beginning of the graph definitions. Name is the name of the graph. Columns is a comma-separated list of alias names from the data collection definitions. In general, all aliases in the columns line must exist in the RRD repository for a graph to be displayed. Type is the resource type that the column metrics belong to. Tutorial 1 is a Node SNMP resource type. Command is the syntax applied to the RRD tool library functions. Those used in this example follow. Title is a horizontal string placed at the top of the graph. Vertical label is a string placed at the left-hand side of the graph. The RRD tool data and variables are def, which is a defined variable based on the RRD file and the DS name. The RRD files are listed on the columns line and referenced as RRD1, RRD2, and so on in the order given on the columns line. The DS name is associated with the alias. In OpenNMS, the DS name is generally the same as that on the columns line. The consolidated function is usually average. Area is a filled-in space representing the value, in this case, tut1. An RGB hex color value follows. Line 1 is a line of width 1 with the value given by the variable, in this case, tut1. An RGB hex color value follows, and that is followed by the legend. gprint prints the value of the variable, in this case tut1, using the consolidated functions average, min, or max in a particular format. Graphing the collected metrics takes into account at least two factors: the period selected for the graph and the number of data points that can be used in the graph. As just explained, the graph is made up of area and line 1. Both of these are based on the cur-estab variable, which is defined as the average consolidated factor of the TCP cur-estab metric collected. In Module B, the RRD element encompassing the collection of the metric TCP cur-estab accepted input every 5 minutes. An average of data collected every 5 minutes was kept for 7 days. An average of data collected every hour was kept for 62 days. And an average of data collected every day was kept for 366 days. Therefore, roughly speaking, graph periods of 7 or less days use the average data collected at 5-minute intervals. Graph periods greater than 7 days, but less than or equal to 62 days, use average data collected at hourly intervals. And graph periods greater than 62 days use average data collected at daily intervals. This graph displays TCP cur-estab data collected within the last hour. A look at the data indicates that the source is the data that is averaged every 5 minutes. Return to the graph. Select a time period of 1 day. A look at the data indicates that the source is still the data that is averaged every 5 minutes. Return to the graph. Now select a period of 1 week. Click on Data. A look at the data indicates the source rate is higher than 1 data point per hour, and so it is still the average collection at 5 minutes, but in order for the graph to fit the page, the sampling of the average collection at 5 minutes is once every 30 minutes, or 1 out of 6 data points. Return to the graph. Create a custom graph period where the start time is older than 7 days in the past, and the end time is less than 3 or 4 days after that. A look at the data indicates a collection period of once an hour. This is the data that is averaged every 60 minutes. Return to the graph. If the graph period is 1 month, the data is that which is averaged every 60 minutes, but there are so many data points that the source is again sampled, this time at once every 2 hours, or 1 out of 2 data points. Return to the graph. Finally, create a custom graph beginning more than 3 months in the past and ending a month later. Click on Data and note the data graphed is that which is averaged every day. Return to the graph. This concludes the section on how stored data is plotted. OpenNMS graphs using RRD tool might need to adjust the value of stored metrics before graphing them. One instance of this is the negativization of output interface metrics. Mathematically adjusting metric data is done using RPN. A surface intro to RPN is provided in the RRD Graph RPN webpage, and the viewer is referred to it for further information. The graph of unicast packets in/out requires the out packets to be negative for the graph. These values are collected and stored as positive values, so it is up to the graph definition to change that. This is the graph definition of unicast packets in/out high speed in mib2-graph.properties. The columns line indicates that two RRD files are used, if/hc in ucast packets and if/hc out ucast packets. The def line assigns if/hc in ucast packets to the variable packets in, and if/hc out ucast packets is assigned to packets out. The cdef, calculated definition, assigns to the variable packets out neg a value using RPN. It works as follows. Put 0 on the stack, put packets out on the stack, subtract packets out from 0. The result is stored in packets out neg. Note that packets out neg is used in the graph element line 1 and area, but packets out is used in gprint. This video covered creating and verifying the tutorial 1 graph definition, explaining the elements of the graph definition, examining how stored data is used to create a graph, examining how the RRD element determines the granularity of a graph, and looking at how RPN is applied to data in graphs. Coming up, Module 11, Part D, Alternate Metric Data Stores, RRD tool fetches and dumps, and tutorial metric with multiple instances.